Hello, today we will discuss about why common emitter amplifier has only 180 degrees phase shift. Why not the common base and common collector amplifiers has 180 degrees phase shift. Out of three configurations, common emitter, common base, common collector, only common emitter has 180 degrees phase shift. That is, output is 180 degrees out of phase with respect to input, but not the common base and common collector, where the output and input are in phase. Why it is? This is the topic of discussion today. So we will consider the common emitter amplifier first. Later we'll go for the common base and common collector. Any transistor, if you buy in the market, that can be either configured as common emitter or common base or common collector. Whatever the configuration, if it works as amplifier, it must be in active region. Active region means emitter base junction forward bias and collector base junction reverse bias. And we know that every transistor will be consisting of two junctions, that is two PN junctions. One is between the emitter and base, the other is between the collector and base. That's why we generally call it as JC is nothing but collector base junction, JE is nothing but emitter base junction. Both are PN junctions only. So both can be either forward bias, both can be either reverse bias, or one can be forward bias, the other can be reverse bias. So active region means emitter base junction forward bias, collector base junction reverse bias. So JE forward bias, JC reverse bias. So if you want to make a transistor as amplifier, at that time it must be in active region. So this is a transistor. When we buy a transistor, which will be consisting of three terminals, emitter, base and collector, and the arrow implies this is symbol of NPN transistor. The arrow implies always the arrow terminal is emitter, opposite is collector, and this side is base. So it is NPN transistor. Collector and emitter both are N type and base is of P type. And we are indicating the collector and collector base junction and emitter base junction. JC collector base junction, this is a junction between collector and base. If you observe, collector is N type, base is P type, so there is a PN junction. And emitter base junction, emitter is N type, base is P type. A junction is going to be forming, that is PN junction between base and emitter. So base emitter junction is indicated with JE, collector base junction is indicated with JC. Whereas there is no junction between collector and emitter, remember that one. Both are N type. So this is a simple transistor symbol of NPN, and if it has to be work as amplifier, it must be in active region. So we must keep emitter base junction forward bias, collector base junction reverse bias. For that one, we require some DC voltage along with resistances. So this is a circuit diagram which provides DC bias. That is, a transistor is going to be keeping in active region with the help of resistors and voltage sources. VBB and RB are going to be applied such that emitter base junction is going to be forward bias. Look at this one. This is base. P side you are applying positive voltage of VBB. That's why this PN junction, that is JE, will become forward bias. At the same time, JC has to be reverse bias. For that one, for N side, we must apply positive voltage. N side positive voltage will make collector base junction reverse bias. So by applying VBB and RB, we can ensure JE forward bias, and with the help of VCC and RC, we can ensure collector base junction reverse bias. We can say now the transistor is in active region. So by applying a constant voltages along with current limiting resistors, we can keep the transistor in active region. So this is generally called as biasing. So whenever you are applying constant voltages and constant resistances, by that time some constant currents flows. Those constant currents are indicating like this: input current as IB and output current as IC. This IC current is flowing through RC in down to up direction, that is upwards direction. Now This is the diagram which is DC bias of common emitter transistor. Now if you apply any AC signal at the input side, that can be amplified. So let us assume you are applying a AC signal. So AC signal is going to be superimposed on the DC voltage VBB. So we are indicating this one with the help of AC voltage source. V input is superimposed on VBB. Now whenever you are applying V input as extra voltage, by that time the previous current is going to be added with some more small current, that is small IB. So this capital IB is constant, that is due to DC bias, and whereas the small IB is due to this extra voltage V in. Because of the small IB, this will be amplified by beta times, and that results in the small change in the collector current, that is plus IC, and that will make the voltage across this RC will be changes by minus IC times of RC. So consider only the AC voltages, because we are interested in the only AC analysis, where the DC voltages are going to be assumed to be 0. So only AC voltage, consider this one. By that time, as V input increases, whenever V input is increasing, at that time this is NPN transistor, base is of P type. So P side you are applying more positive, that makes emitter base junction is going to be more forward bias. Whenever emitter base junction gets more forward bias, by that time this small IB will increase. When small IB increases, small IC increases by beta times. So small IC, change in collector current also increases. Whenever change in collector current increases, at that time the magnitude of IC and RC is going to be increases. Magnitude of IC RC, we are neglecting the polarity. Magnitude of IC RC is going to be increases since IC is increasing, which is nothing but V0. That is magnitude of V0 is increasing. Whenever V input is increases, at that time magnitude of V0 is increasing. But if you observe, V input is increasing positively, whereas V0 is increasing negatively. Whenever input signal is increasing positively, output is increasing negatively. So there is a change in sign, that is nothing but phase inversion. So note that V input is increasing positively, whereas V0 is increasing negatively. That is V0 is out of phase with respect to V input. Hence V0 is 180 degrees out of phase with V input. That's why common emitter is going to be having 180 degrees phase shift. Next we will consider about the common base. A simple common base, this is a transistor symbol of NPN, where arrow always implies emitter, the opposite is collector, and this side is base. Now base terminal is common for both input side and output side. Input is taken across emitter, output is taken across collector, and the transistor must be in active region to work it as amplifier. So again we are using the DC voltages and resistors to keep this transistor in amplifier mode, so that whenever we keep the transistor in amplifier mode, there will be existence of some DC currents. Those DC currents are indicated as IE, which is going outwards, the arrow shows. Emitter current is input, which is going to be going outwards, and IC is the output current, which is coming inside, because it is NPN transistor. And look at this one, the voltage VEE is going to be making the emitter base junction forward bias. Since it is NPN transistor, for N side you must apply negative terminal, for P side, that is base, you must apply positive voltage. So VEE and RE will keep emitter base junction forward bias, VCC and RC will keep collector base junction reverse bias. Now it can act as amplifier, it can amplify the input signals. Let us assume apply input signal. Whenever you are applying input signal, a small AC signal we are applying as V input. So because of this one, there will be a change in emitter current that is indicated with plus small ie. This small ie is result of V input and capital IE is going to result of VEE. Remember that. Small IC is result of VCC and capital IC is result of VCC and small IC is result of this V input. So IC is equal to alpha times of IE. So now we will see whether it is having 0 degrees phase shift or 180 degrees phase shift. As V input is increasing, look at this one. As magnitude of V input increases, magnitude of V input increasing is nothing but, strictly speaking, V input is increasing negatively, like this, -2, -3, -4, -5, like this you are increasing the magnitude, but the polarity is negative. So whenever the input voltage is you are applying like in that way, at that time that makes more negative towards this n side, that is emitter is of n type, and you are applying more negative voltage because magnitude of V input is increasing. So negative value of V input is increasing, that makes emitter base junction more forward bias, since n side you are applying negative voltage. Emitter is of n type because it is NPN transistor. So n side you are applying more negative voltage, that is nothing but emitter base junction more forward bias. Because of that one, IE increases. Whenever IE increases, IC also increases, because IC is equal to alpha times of IE. Whenever IC increases, V0 is equal to minus ICRC. So magnitude of V0 is going to be increases. Magnitude of V0 is increasing is nothing but value of V0 increasing negatively. So as V input is increasing negatively, V0 is also increasing negatively. If you take the opposite case, at that time V input reduces negatively, V0 also reduces negatively. So the polarity of V input and V0 are going to be same. So V input and V0 polarity is same, that implies nothing but output and input are in phase. So there is no phase difference between V input and V0. Both are increasing negatively or both are decreasing negatively. That implies nothing but V0 and V input are going to be in phase. That is, there is a 0 degrees phase difference between input and output. Now we will see about the common collector. This is a simple common collector amplifier along with V input, because already we have seen how to apply the DC bias, how to apply the AC signal. So here this is VBB is going to be creating capital IB current that results in capital IE, and whereas small V input is going to be resulting in small IB that again results in the small IE. And V0 we are only considering the AC voltages, so that it will be treated as IERE, because the current is also flowing in the same direction, plus to minus. So V0 is plus IERE. Now look at this one. This is the NPN transistor, and collector is going to be now common for both input side and output side. Input is base, output is emitter. So this is going to be called as common collector configuration. The same common collector configuration can be redrawn in this manner. It looks like common emitter, but we are taking output across emitter, and collector is going to be connecting towards VCC, where it is going to be connecting to ground for the AC analysis. So that collector is going to be assumed as common for both input and output. We know that one for AC analysis, DC voltages are going to be neglected or considered as 0. So VCC is going to be making it as 0 for the AC analysis. By that time, this collector is going to be connecting towards ground. So for AC equivalent of circuit, collector is at AC ground. By that time, the collector is common for both input, that is base side, and output, emitter side. So this circuit is also called as common collector. It is also known as emitter follower. And these are the currents. We will see how it is providing 0 degrees phase shift. Same diagram again we are going with. V naught is nothing but voltage drop across Re, that is nothing but small ie into Re. We are only considering the AC voltage. As AC signal increases, that is as V input increases, whenever V input is going to be increases, at that time small ib increases. Small ib increases is nothing but small ie increases. Small ie is 1 plus beta times of ib. So small ie increases. Whenever small ie increases, V naught, whose value is ie into Re, so V naught increases. If you observe, V naught and V input both are increasing positively, that is both are having the same polarity, so they are in phase. Both V input and V naught are increasing positively, that implies nothing but both are in the same phase and there is no phase difference between V naught and V input. That implies common collector has 0 degrees phase shift between output and input. The only amplifier, common emitter, is going to be having 180 degrees phase shift. The others, common base and common collector, are having 0 degrees phase shift. Thank you.